Imagine you're driving a robotic rover on Mars. You're sitting comfortably at mission control on Earth, eyes fixed on a screen, controlling the machine as it explores the dusty Martian surface. But here's the catch. If the rover stubs its robotic toe on a rock, you won't find out for nearly half an hour. Why? Because even signals moving at the speed of light need time to travel the vast distance between Mars and Earth. There's no such thing as real-time control in space, not at these distances. Instead, every command you send, every image you receive, is subject to the universe's cosmic delay system. It takes light and radio waves, which are part of the light spectrum, between 5 to 20 minutes to cross the space between Earth and Mars, depending on the planet's relative positions. This delay means that modern Mars rovers, like Perseverance and Curiosity, must operate autonomously. They're programmed to make decisions on their own, to avoid hazards, pick paths, and even pause to reassess, because the message from Earth simply can't arrive fast enough to help in time. In that way, the speed of light becomes more than just a law of nature. It becomes a boundary between presence and distance, between now and later, between control and freedom. But the reach of this cosmic limit isn't confined to deep space missions. It shapes our daily lives on Earth in quiet, invisible ways. For instance, consider your favorite streaming service. When you fire up a documentary or binge a series at midnight, every pixel, every audio wave, every frame of your video travels to your device as bursts of light moving through fiber optic cables. Yes, fiber optics are essentially light highways, glass threads that send laser pulses across oceans and continents. And yet, those light pulses still obey the same universal rule. They cannot move faster than 299,792 kilometers per second. And because they travel through a medium, glass, their speed is even a bit slower, about 2/3 of light speed in a vacuum. Add to that the routing delays, signal boosts, and server handshakes, and suddenly, your instant entertainment is the result of an extraordinary dance against nature's clock. So whether it's a Martian rover or a Netflix binge, you're feeling the effect of light's speed limit, in space and at home. Now, to some, this might sound like a constraint, like the universe is holding us back. But in reality, this cosmic limit provides structure. It enforces cause and effect, anchors the direction of time, and transforms the universe from a chaotic soup into a coherent narrative. Without this speed boundary, there would be no before or after, just a blur of events without order. Imagine trying to tell a story where the middle happens before the beginning, and the ending flashes into view without a cause. That's the kind of chaos we'd face in a universe without light's speed limit. Instead, this law gives us a timeline, a past we can remember, and a future we can reach. And yes, ironically, the fastest thing in the universe is also what slows us down. It's what prevents us from instantly controlling Martian robots or communicating with alien civilizations light years away. It's the bottleneck of cosmic communication. But that's precisely what makes space so majestic, so mysterious, and so quiet. There's no universal live feed across galaxies. What you see when you look at a distant star is how it looked millions of years ago. The light you catch tonight from a galaxy 2.5 million light-years away began its journey before humans ever walked the Earth. That galaxy may not even exist anymore, but we wouldn't know, because its last message, its last photon, hasn't arrived yet. This delay turns the universe into a living museum, where every star is a time capsule, and every beam of light is a silent postcard from the past. It's a profound thought. We are always seeing the history of the cosmos, thus never its present. And that's not just true of galaxies. It's true of everything. Even the moon is seen as it was 1.3 seconds ago. The sun? You're seeing it 8 minutes in the past. This isn't a flaw. It's a feature of a universe governed by light-speed logic. A universe where every event, every interaction, every discovery is guided by the perfect delay. Long enough to teach us patience, short enough to allow understanding. In fact, that delay may be crucial for life itself. If information moved faster, systems might destabilize. Energy could arrive before a cause was complete. Atoms might never settle. Planets might never form. The delicate balance of forces that allows molecules, biology, and consciousness to exist could unravel. So perhaps this limit isn't just a rule. Perhaps it's a gift. A cosmic pace that allows stars to shine steadily, planets to orbit gracefully, and light to tell the stories we were born to interpret. Here at Infinity Beyond, we believe that story is far from over. In our next segment, we'll dive into one of the most haunting ideas in physics. What happens when time stops altogether? When light slows to a crawl near the edge of existence? When space and time fold under the weight of mass? Yes, we're heading into the event horizon, the ultimate edge of reality. But until then, the next time your video buffers, or your Mars rover sends back a photo, or you look at a saucer and wonder if it's still shining, remember this: it's not a delay. It's a reminder that everything has its time, and light always arrives exactly when it should.